All right, so with applications of conic sections, you want to read the problem to identify what type of conic section is it explaining: an ellipse, a hyperbola, a parabola, or a circle. In this case, this says there's a whispering gallery that has an elliptical room, so that automatically tells me it's going to be an ellipse. And it says that it's 64 feet wide, and it says that it's 136 feet long. So since that's the case, that means my 136 represents the major axis, and my 64 represents the minor axis. So that's the vocab terms that represent these two given pieces of information. Then it says, find the equation that models the shape of the room. Well, your major axis is 2a. So if we solve for our a value, that would be 68. And if we solve for a squared, that's 4,624. Your minor axis is your 2b. If we divide by 2, we get 32. And if you square 32, you get 1024. Okay, so because I drew this as a horizontal ellipse, that means it's going to be x squared divided by 4624 equals y squared, plus y squared over 1024 equals 1. Then it says, where should people stand to hear each other? Well, they hear each other at the foci. So that means we have to figure out what is the major foci. Your foci for an ellipse would be using the formula a squared equals b squared plus c squared. We have our a squared is 4624 and our b squared is 1024. So if I subtract that off, I'll get 3600, which means if I square root that, I'll get plus or minus 60, which means that it says, where should people stand to hear each other? They should stand 60 feet from the center. So that's our first application. Our next application says that there's an epicenter near a certain city. That city, it says the epicenter is located 5 kilometers to the east, and it's located 3 kilometers south. So if that's the case, then because there's a radius of 5 kilometers, then the formula that would represent this information is x minus h squared plus y minus k squared equals r squared. I knew it was a circle formula due to the fact that it's talked about a radius. So our center, which is where the epicenter is, since it's 5 to the right and 3 down, that would be x minus 5 and y plus 3 equals your r squared is 25. Now we want to identify if the center is in this epicenter, if it's going to be affected by the earthquake. Well, if your epicenter is at 5, -3, then your city was at the starting point at 0, 0. So if we plug in 0 for our x and 0 for our y, we would get 25 plus 9, which is equal to 34. 34 is bigger than the area of 25, which indicates that the city is on the outside of the epicenter. So therefore, it's not going to reach the city. The next problem we have says that it has a parabolic reflector. So if it's a parabolic reflector, then that tells me it's going to be a parabola. So I'm going to draw the shape of a parabola. It says that the bowl is 12 inches wide. And it says that it's 8 inches deep. So it wants to know if the filament of the light bulb is located at the focus, how far from the vertex is the reflector. So essentially, you're trying to find your p-value. Okay, so this represents the equation x squared equals 4py. Well, if we look at this on a number line, if we graph the parabola, considering it was 12 inches wide from rim to rim, that means that this distance is 6 inches. So therefore, because the depth was 8 inches, that means that this coordinate point here would be 6, 8 on the unit circle. I mean, not on the unit circle, I don't know why I said that, on the parabola. Okay, so if I plug it in, 6 squared equals 4p 8, then we have 36 equals 32 p. Divide off the 32, and you get p equals 9/8 inches. So, and then you can plug that in and get the decimal. I think it's like 1.125, but ultimately that means that's the distance from the vertex to the focus, which is what it wanted. So then we have a problem that has a cable suspended on a bridge, like so. It says that the roadway is horizontal and it's 80 meters long. So it's 80 meters long. And it says that it's supported by vertical wires where the longest one is 20 meters. And the shortest one is 4 meters. So that tells me this should actually go down to here because this one is at 4 meters. And then over here, it's also 20 meters. So if we graph this on a number line or on a graph, that indicates to me that the vertex is at 0, 4. And we also have a coordinate point here because the entire thing is 80, that means it splits into 40 and 40. So that means this coordinate point on the graph is at 40, 20. So with that, we can use the formula x minus h squared equals 4p y minus k. Your vertex was at 0, 4, which is your h and your k. So that means I can plug in my h as 0, so I'm left with x squared, 4p, your y minus 4. Then we have to try and figure out the p-value. Well, considering I have a coordinate point that I know is x, y, my x is 40, and my y is 20, and my 20 in for my y, then I get 1600 equals 4p times 16. I can divide off the 16 so that I know what 4p equals. So therefore, 4p equals 100. I want to write the equation that represents this information. So that means my equation would be x squared equals 100 y minus 4. So that's the equation that represents this information. Then it says find the length of a supported wire attached to the road 20 meters from the middle. So that's 20, y. So I can find out how long the wire is by plugging in 20 for your x. And your y is what you're trying to find. So 20 squared would be 400. Divide off the 100 and you get 4. Add over the 4 and y equals 8 meters.